Welcome to another episode of Electronics Made Easy. Today we're going to talk about AC. We're going to talk about how to make a drop cord, how to wire up receptacles, and how to wire up light switches. We're going to start with, where does AC power come from? Well, it comes from a power plant, most likely. There are several kinds. There are coal-fired, there are oil-fired, there are hydroelectric plants, there are nuclear plants. There are all kinds of ways to make the electricity. We will go into that in another episode, but it leaves the power plant, then it goes through a set of transformers and the voltage is boosted. Then it goes through the high power lines and it goes through the electric lines and it ends up going to a transformer near your house. And then it is stepped back down to a lower voltage and then it goes into your breaker box at home. Most homes have a 200 amp breaker panel coming in from the outside, and it is then subdivided into smaller breakers. Most of them you will see are in the 20 amp range. There are 110 volt, 120 volt breakers, and there are 220 volt and 240 volt breakers. The incoming power in your house can vary from 110 up to 125 volts. It depends on the day and the load. The power company tries its best to regulate it at a constant voltage, but it honestly isn't. It changes. Now, when you do work in a breaker box, always be sure to put labels on all of the breakers. That way you're not confused later. If you have an emergency, it is easy to see which breaker you need to turn off. There are three distinct categories for wiring. There is residential, which is your home. There is commercial, which is like a business, a grocery store, anything that's commercial, that where things are sold or bought, or an office building would fall into that category. And then there is industrial. And all of these are controlled by a government agency called the NFPA, which is the National Fire Protection Agency. And the National Fire Protection Agency created a book. And that book is used by all electrical people, and it's called the National Electric Code book. It is a large book. It has thousands of rules in it, and you have to go by all of those rules. You must follow those rules in order to do any kind of electrical work. It's just the way it is. Okay, let's talk very briefly about the breaker box. The breaker box brings power from the power company. It goes through their meter, usually on the outside of your home, and then large wires go from the meter base to the top of the breaker box. And there is a main breaker at the top of the box which is rated at the current of your box. And then bus bars are a bus bar is a metal bar that carries the current to the different breakers. Once you've put the breakers in, you bring the wire out. The hot wire comes out of the breaker. So the black wire comes out of the breaker. Then you have a white wire and a ground, and they go to what is called a ground bar. And the ground bar is where you take all of the neutrals and all of the ground. If you have a second box that is downline from your main box, the grounds and the neutrals must be separated according to the NFPA rules. Let's talk a little bit about the kind of wire that we use in a home or residential wiring. It is called NM type wire, or Romex, which is a name brand, but it's the most common name used for this type of wire. Before we get into the actual wiring of things, there are a couple of things that we need to understand about, especially residential wiring and when we wire electrical plugs and switches and those kind of things. Everything is wired in parallel in a home. The reason for this is parallel gives us exactly the same voltage on every branch that we have. If you put anything in series, it's going to drop voltage every time it goes through something. And if it does, then the next plug in line would not have the proper voltage to run your device that you've plugged in, whether it be a lamp or a drill or your microwave. You've got to put these in parallel. In parallel, voltage is the same on every branch and current can vary on every branch. Okay, let's get into some of the more interesting things. Let's actually do some wiring at this point. I think you may learn a few things. Okay, let's start with a plug that goes on a drop cord. Everybody needs to know how to make a drop cord, so we will cover that first. First of all, we're going to strip the wires back. And we're going to get the black, the white, and the green. Now we've got those. Now let's open up the male plug. Forget this part. You've got to take all the wires and stick them through the back before you start. Get this on here. You loosen it up with these two screws. Once you got it on, you can tighten it back up with the same two screws. So we've got green, we've got white, and we've got black. Okay, black is always going to be the hot, and hot goes to the gold screw. So we see a gold screw there, so we know that the black wire goes to the gold. Then we tighten it down. Now we inspect it to make sure there are no tiny wires sticking out anywhere. And I don't think there are. Nope, no small wires. Okay, the next one is going to be the white wire, which is the neutral or the AC return line. So that goes to the silver screw. So now we've got the silver, we're going to tighten it up. And now last but not least, we're going to make sure that we get this ground on here. The ground is absolutely essential. The ground is green. So now we're going to tighten up the ground terminal. And these are compression fittings, by the way, which are my favorite. If I've got to have something, I would prefer it be a compression terminal. Now, give everything a good tug and make sure it's good and tight. One final inspection to make sure there's nothing loose. So now we're going to slide this on here, and if you look inside, you'll see there are 3 screw holes, and then you've got that little groove right there. Now, if you line that groove, which is right here in line with the ground, if you line those two up, it should pop right in easily. Now we're going to tighten this up. This is a 110 volt 120 with a 15 amp capacity. That is what this plug is rated at, so you should not run more than 15 amps through it. And as we will learn later, you will know that you must match the wire size to the current. And in this case, we are using a 16-3 rubber cord, which means it has 3 number 16 wires in it, which is capable of carrying the 15 amps. Now we give it a good tug, and there you have it, a complete plug. All right, let's do the other end of the drop cord now. Let's first of all take this apart, and again, you have to loosen this up so you can get all the wires. And now we're going to take the wires and we'll slide them through. Didn't loosen quite enough, and I have to loosen some more. So let's go through. Okay, so it's on there. Now we're going to cut these back considerably in length, because we don't need a lot of length inside. So we're going to cut all 3 wires. All right, now we're going to strip all 3 wires. Okay, now all 3 are stripped. So we're going to do this the same way we did the other end. This is the female end. This is the male end we've already put on. This is the female end. And the same scenario applies here. The black wire will go to the gold screw, and the white wire goes to the silver screw. And last but not least, the green wire goes to the green screw. Now I'm using 16-3 rubber cord, which means there are 3 number 16 wires. They are stranded, not solid. You need the stranded wire because you need the flexibility in a drop cord. Now we're going to check and make sure there are no wires hanging out. We're going to check each one to make sure it's good and tight. I think everything looks okay, so we're going to put the cover on, and it's the same scenario that we had before. We have the little notch right here, as you can see, and then if you look inside, there's going to be a groove in here. So we're going to line that notch up with that groove. If we do that, everything should go right on. And that is how you make a drop cord. Now you can make this any length that you would like. Of course, this one's only a couple of 3 feet long because we're doing a demonstration, but you can make this 100 feet long if you have 100 feet of cord. So that's how you make a drop cord.